In our last video, we looked at combining the derivative of a cosine function and the chain rule. So what we'll do now is we'll have a look at how we can expand this to using the cosine function with a product rule and a combined function. So what we have here is we've got a function 2x multiplied by another function. So we're going to use our product rule. So we can think of this as y equals u times v. I'm going to let u equal 2x. So therefore our derivative of u is going to equal 2. And we're going to let v equals sine x. So our derivative of v is going to equal cosine of x. So remember, if y equals uv, then our derivative is going to be our derivative of u times v plus u times our derivative of v. So u dash v plus uv dash. Simple matter of substitution. So u dash is 2, v is going to be sine x, plus u is 2x, and our derivative of v is cosine x. That's it. What we'll look at now is another function. Now we could do this using the quotient rule, but we'll look at this one using the product rule. So we can rewrite this as y equals x times cosine of x to the power of -1. So here we still have u multiplied by v. So if u equals x, then the derivative of u equals 1, and if v equals cos x to the power of -1, then we're going to use our chain rule here. We've got a function within a larger function. So our larger function, the derivative, is going to be -1 times cos x to the power of -2 multiplied by the derivative of what's inside our function, which is going to be negative sine of x. So I can rewrite this as negative times a negative positive. So I've got sine x, and cos x to the power of -2 is the same as dividing by cos x to the power of 2. So I can write that as cos squared x. So if I substitute that in, my derivative of y is going to be derivative of u times v plus u times the derivative of v. So u dash is 1, v is cos x to the power of -1, which I can think of 1 over cos x, plus u, which is x, and then v dash, didn't write that there, the derivative of v is sine x divided by cos squared x. Now I could leave it like this, but I could get it all down to one common denominator. If I multiply the top and bottom of this one by cos x, I'm going to get cos x plus x sine x over cos squared x. And then we have a combination of using our derivatives of our trig functions of sine and cosine x, and also using our chain and our product rule.